Okay, so difference of squares is the name of the rule that we are doing today. Again, we're skipping over 5.7. We'll come back to it on Wednesday, just for block days and skinny days, or Tuesday if you're watching this and you're in an even hour. Why do we need this rule? So this is the same thing you guys did in your quick write, is if you multiply two binomials that look like this. So I've got 5x and 4 and 5x and negative 4. When I go multiply those together, top left corner is going to be 5 times 5, so that's 25. And then x times x is x squared. Top right corner, 5x times negative 4x is negative 20x. I misspoke, 5x times negative 4. Put another extra x on there. Bottom left-hand corner, 4 times 5x is 20x. And then bottom right-hand corner, 4 times negative 4 is negative 16. When we go to write our final answer, 25x squared comes first. We always do it in standard form, highest to lowest. This 20x and negative 20x, what do? They cancel out because they're the same number. One's positive, one's negative. They just cancel. So I put a minus 16 on the end. Okay. From the problem that you saw on your quick write, which did the exact same thing, just with different numbers, and this problem, we notice that your x terms cancel out both times. Yeah? Okay. What do we notice about the original problem? They're the same number, so 5x plus 4, 5x minus 4. So they are the same numbers, but one has to be plus and one has to be minus in order for this special rule to work. When this special rule works, 25 and 16, those are perfect squares. So a number times itself is a perfect square. And then another way to say subtraction is difference. So the name of this rule is called difference of squares. So if you have two numbers that are perfect squares, and what are the words I'm trying to say? You have two numbers that are perfect squares, and it's a difference in between them, you're subtracting, then we get to use this rule. And what this rule is that if we have a squared minus b squared, that can be factored out to be a plus b times a minus b. So one's plus, one's minus. So that is our general rule for difference of squares. Okay. Before we dive into our examples, the first thing that I want to do is make a list of all of our perfect squares because it's going to make your life easier. So 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. Where am I? 8 times 8 is 64. And 9 times 9 is 81. I'm going to keep going up to 15. 10 times 10 is 100. 11 times 11 is 121. 12 times 12 is 144. 13 times 13 is 169. 14 times 14 is 196. And then 15 times 15 is 225. So I'm just writing those all down so that I've got them handy. You'll start memorizing. Like, we know that 10 times 10 is 100, and then you can memorize like the ones below and above that. Okay, so we've got our rule here. Right here, it's written a little bit differently. I put the x in here, so ax squared. Technically, that a and x should be in parentheses right there. I remember that being a typo from last year. Okay, so for these problems, this is all we do. X squared is our first term. So the first thing that you're going to ask yourself is what times what is x squared? If you need to write it out over here, you can. It's just x. So x times x is x squared. Then the other thing you're going to look at is the 36. What number times itself is 36? 6. So then we'll have 6 times 6. If you need to write it out over there, write it out. Our answer is literally just x plus 6 times x minus 6. Because remember, factoring is the opposite of multiplying. If I were to multiply that out, my middle term would cancel. I would be in business. Okay, the next one, we've got 4x squared. What number times itself is 4? 2. And then x times x is x squared. So in this one, my first piece of my answers is going to be 2x. And then 81 is 9 times 9. So my answer in this one is going to be 2x plus 9 times 2x minus 9. One's always got to be plus, one's always got to be minus. You could technically do the minus one first and then the plus one. I've never met someone that's done that, but it's not technically wrong. Okay, 2 more. 25x squared. What number times itself is 25? 5. And then that first one's always going to get an x. And then 49, square root of 49 is 7. So what number times itself equals this is the same thing as asking the square root of. Because that's asking what number squared would be this. So my answer here is 5x plus 7 times 5x minus 7. Okay, very last one, 9x squared. What's the square root of 9x squared? 3, and then also on x. And then square root of 1. What number times itself is 1? 1. That one's kind of tricky. People are like, is it 0.5? No, it's not 0.5. Just 1 times 1 is 1. Okay, so my answers here are 3x plus 1 and 3x minus 1. You do not need to write down this and this. I was just doing that to show people as we were going through the notes. Any questions right now? Do we agree this is easier than what we've been doing for the last week? Yeah? Yeah? Okay. Thanks, Max, for being on board with this. Okay,